For 12,000 years, the Levant has functioned as a geographic bottleneck, a narrow strip of habitable land where human populations constantly collided, migrated, and settled. When an ancient population looks physically different from the people who lived there before, archaeologists must determine if the change is a result of local adaptation to the environment or a signal that the inhabitants were replaced by a new group. This map plots the key archaeological sites containing human remains from the Pleistocene through the Hellenistic eras, mapping a corridor that stretches from the Sea of Galilee to the Dead Sea. Historically, researchers relied on the cultural record, pottery, seals, and texts to track these groups. But artifacts are vulnerable to being traded, imitated, or adopted by unrelated peoples. While cultural artifacts trace the movement of ideas and empires, they cannot always confirm demographic shifts. To track the actual physical movement of human bodies, we have to look to the biological archive, the bones and teeth. The central methodology for tracking skeletal changes over vast stretches of time is diachronic morphometrics. By taking precise measurements of skulls and jaws, we can quantify physical changes as they occur across thousands of years. These measurements reveal two distinct mechanisms of change. The first is continuous in situ microevolution, driven by local environmental adaptation. The second mechanism is displacement. This appears as a sudden, discontinuous shift in morphology, indicating that a foreign population migrated into the region. Local adaptation creates a smooth trend line as generations gradually adjust to their surroundings. A migration event creates a sharp break in the data. By overlaying specific epigraphic evidence, dated seals and written texts, onto these biological trend lines, we can establish the exact origins and identities of these populations. Isolating the continuous evolutionary signal from the migratory noise clarifies the actual history of human movement in the Holy Land. We begin by establishing a deep time baseline, opening our timeline in the late Pleistocene, around 92,000 years ago, and running through the early Bronze Age. To track continuous adaptation, anthropologists measure a specific biological metric, the size and robusticity of the human mandible and teeth. This chart plots diachronic trends. The topmost line tracking tooth size shows a steady, continuous reduction. Between 11,000 and 3,000 years ago, the Nautifian, Chalcolithic, and early Bronze periods plot cleanly along a single, unbroken regression line. The selective pressure driving this specific physical change was the Neolithic agricultural revolution. The introduction of agriculture brought a reliable supply of carbohydrates, and the invention of pottery allowed those grains to be boiled into soft foods. Humans simply no longer needed the heavy, robust chewing mechanics required by a hunter-forager diet. But this shift came with a corresponding side effect in the biological data, a spike in dental hypoplasia during the Chalcolithic period, affecting nearly 90%. The pre-MBII populations, the Natufian, Chalcolithic, and early Bronze Age samples, cluster tightly together, sharing a highly consistent morphological pattern. They share a specific cranial trait. These populations are dolichocranic, meaning they possessed long, narrow skulls. But look at the data for the Middle Bronze II period. It breaks sharply from the 10,000-year trend established by the eras preceding it. MB2 skulls abruptly become brachycephalic. They are significantly shorter, higher, and wider, interrupting the continuous evolutionary trend. We can see this deviation by looking at the actual skeletal remains. This skull from the MB2 period at Sasa shows a distinct, high-vaulted, rounded shape. Craniofacial shape, specifically the width of the face and nose, is often a physiological response to climate. Adapting to cold or temperate environments typically favors shorter, wider cranial structures to preserve heat and moisture, which are disadvantageous in hotter, more arid climates like the Levant. Because the MB2 population shows a sudden shift toward these brachycephalic traits, it suggests they originated from a damper, more temperate climate and migrated into the region. This cranial anomaly is biological evidence of a demographic replacement, a moment where the local gene pool was overwritten by an entirely new people. Moving forward to the late Persian and Hellenistic periods, we can test how this biological data aligns with established textual history. Anthropologists examined the craniofacial profile of Hellenistic-era Jewish populations from northern Levantine sites like Sasa and Meiron. Their morphology connects directly back to the Middle Bronze II anomaly, sharing the exact same short, broad, brachycephalic skull structure. But a 4th century BC discovery made in a desolate canyon north of Jericho provides a strict historical counterpoint, the Wadi Dalyeh. Inside these caves, researchers found a cache of skeletal remains belonging to Samaritan refugees who were slaughtered while fleeing the armies of Alexander the Great. When researchers took precise cranial measurements from these specific Wadi Dalyeh Samaritan skulls, the results were unexpected. Contrast the two groups. On the left is the short, broad, brachycephalic profile of the contemporary Hellenistic Jewish populations. On the right is the Samaritan profile. The Samaritans possessed exceptionally small, narrow heads. This morphology aligns them with the ancient pre-MBII core population of the Levant. The Hellenistic Levant was not biologically monolithic. Distinct cultural groups maintained divergent genetic lineages despite living side by side in the same geographic corridor. The specific artifacts found with the Wadi Dalyeh refugees establish their precise political context. These are the Wadi Dalyeh Papyri, a collection of 4th century BC legal documents executed in Samaria. The text contains a crucial piece of epigraphic evidence, the appearance of the name Sanballat, the governor of Samaria, confirming the political identity of the refugees. Attached to these papyri are official sealings executed before the governor and prefect, inscribed in Paleo-Hebrew and Aramaic. The cache included over 100 impressions and seal rings bearing very specific Persian-style iconography. A prominent visual motif on these seals depicts a Persian king or deity lifting 2 animals by their hind legs. This seal motif anchors the artifacts to a precise geopolitical era, the final days of Persian influence, immediately prior to the Hellenistic conquest. Because the bones and the papyri were buried together in a single deposit, this cave anchors highly specific cultural epigraphy directly to a distinct biological profile. Texts tell us what ancient people believed and who they fought, but only by fusing that epigraphy with the morphometric data can we prove exactly who they were and where they came from.